Hi students, welcome to today's session on data structures. So this is an important subject in your current semester 2-1, and this is the book you need to refer to understand the topics data structures, algorithms and applications in C++ by Sartaj Sahani is the author, and the book is published by Universities Press. Myself, this is Professor V. Sachnan Reddy, our head of the department. So let us begin our session today by briefly going through the contents of this session. First, we'll look at what exactly a data structure means, and then the types of data structures available, and what are the possible operations that we can perform on data structures, followed by the most important topic, abstract data type, and its meaning, its advantages, followed by the preliminaries of algorithms. That means what exactly an algorithm is and how to identify the time and space complexity of an algorithm which is already designed. And then we will look after a few algorithms for solving searching problems as well as sorting problems. There are actually linear search, binary search, Fibonacci search, and insertion sort, selection sort, bubble sort, quick sort, radix sort, and merge sort algorithms. We will design all these algorithms and then we'll try to estimate their efficiency in terms of time complexity and space complexity. So this is a brief overview of the syllabus that we are going to cover in our first session, in our first unit. And coming to the data structures definition, it is simple. It is the way of storing and organizing data in a computer's memory so that the data is efficiently used. So as simple it is, data structure is nothing but the way of storing the data in memory so that it is used efficiently. What does this efficiency means? And let us understand it with the help of an example now. Suppose you have 10 elements to store with respect to a particular program in C language, because you already know C language. Now you have two options. Option one is declare 10 variables and store all the 10 values into the different 10 variables. That is first option. And the second option is, because all the data is interrelated, belongs to the same program, use an array to store all the 10 elements so that they are stored in the memory side by side. That means in adjacent memory locations. So obviously, when you have interrelated data, the better option is always choosing an array to store all the 10 elements. The reason is, if you store all the elements at one place, it will be easy to you to access them and it will be easy to work with the data. So based on the data structure that you select for storing your data with respect to a particular application decides the efficiency of that application. So you need to be very careful while selecting the corresponding data structure for storing your data. So for that, to make that decision, you need to understand what are the possible data structures available for storing your data, and what are their pros and cons, their advantages and disadvantages. And then you should understand what data structures are suitable for what kind of applications. So once you understand all these things, then it will be easy for you to select a proper data structure, a suitable data structure for storing your data, right? So that is the reason why this subject has become very important, because the efficiency of the application that we develop in any programming language depends on the proper data structure that we select. So we should have that knowledge to select a proper data structure for the corresponding data, right? So we are going to study the possible data structures available throughout this subject. and then where actually they are utilized. If you look at this diagram, the classification of data structures, uh, uh, partially few data structures in this diagram. At the broadest level, there are two types of data structures. One is primitive data structure and the other one is non-primitive data structures. You might have studied all these primitive data structures in your C language: uh, integers, floats, characters, and booleans. And coming to non-primitive data structures, you know only few of them. If you observe the difference between primitive data structures and non-primitive data structures here, in primitive data structures, integer, float, character, boolean can store a single value only. So basically, primitive data structures are meant for storing single values, right? And when it comes to non-primitive data structures, you can see they are list of values. That means when you want to store multiple values, you go for non-primitive data structures. Again, in C language, you saw how to utilize arrays for storing multiple data elements at one place. You saw structures to store multiple elements at one place. You saw pointers to store multiple elements at one place. You saw unions and so on. So they all come under derived data types or non-primitive data structures pertaining to a particular programming language. But when it comes to data structures, non-primitive data structures are again classified into two types. They are linear data structures and the other one is non-linear data structures. This classification is very important because whenever we talk about data structures, this classification is very important. We don't bother about primitive data structures because they will be given by the programming languages straight away. So we don't bother about them, we'll directly utilize them. Whereas when it comes to non-primitive data structures, we need to build them. We need to build according to our application requirements. Therefore, so data structures means that non-primitive data structures in our subject. Right now, uh, if you look at the types of linear data structures, arrays are again a part of your programming languages. They are directly available. You can utilize them. And linked list, we will build it logically, and then stacks, and then queues. When it comes to nonlinear data structures, there are two types: trees and graphs. Our entire syllabus of data structures in this 2-1 is about linked lists, stacks, queues, trees, and graphs. 5 units. Right now, to understand the difference between linear data structures and non-linear data structures, uh, let us have a look at this. In linear data structures, the elements are actually stored sequentially in an orderly manner, which means adjacency is always preserved, either physically continuous memory locations or logically continuous memory locations. But the thing is, all the elements can be accessed straight away, starting from the first element and moving towards the end element. There will be no deviation. They are maintained in an orderly manner. Right? When it comes to nonlinear data structures, it's not possible to access all the elements from the beginning to end. There will be some interrelationships exist between the elements, right? Therefore, when you start at a particular element, you can reach only few elements which are related to that element. Similarly, when you start at another element, you can reach only few elements which are related to that element only. So that is why linear data structures are sequential, whereas nonlinear data structures are not sequential. We cannot access them. There will be no proper order. There will be no uh, direct relationship between elements, right? And memory utilization in linear data structures is actually inefficient, whereas in nonlinear data structures, memory utilization is efficient. They occupy very less memory compared to linear data structures. And linear data structures are single level. Single level means, like for example, an array is a collection of adjacent elements. It's a single level data structure. When it is nonlinear data structures, there are two types, trees and graphs. Both of them are multi-level data elements. So they represent the data in the form of a hierarchy, level 1, level 2, level 3, and so on. There will be number of levels to store the existing data of the application, right? And linear data structures are very easy to implement, but non-linear data structures are very difficult to implement, but efficiency is better than linear data structures. So this is about linear data structures and non-linear data structures. You can simply remember that in linear data structures, elements are stored sequentially, whereas in non-linear data structures, elements are not stored sequentially, they are stored in hierarchy manner, right? Right. I'm going back again. So if you look at this linear data structures and non-linear data structures, it is mentioned here as arrays and linked lists are also linear data structures. But actually, the truth is, linear data structures are stacks and queues only. Non-linear data structures are trees and graphs only. But we can implement non-linear data structures as well as linear data structures by using either arrays or linked lists. So assume these two, arrays and linked list, as a representation of linear data structures as well as non-linear data structures. That means whatever data structure it is, either it is linear data structure or non-linear data structure, you can implement them either using arrays or using linked lists. I repeat again, irrespective of the type of data structure, we can implement them by using either arrays or linked list. Then why these two are written over here under the category of linear data structure? Because they themselves represent a linear data structure. They are used for representing all these other data structures, as well as they represent themselves as a linear data structure. So that is the reason why they are mentioned under linear data structures, right? So this is the classification of data structures. Again, have a look at it. There are two broad classification data structures: primitive data structure and non-primitive data structure. Primitive data structures are the basic elements provided by any programming language, C, C++, Java, or any programming language. Whereas non-primitive data structures are derived from the primitive data structures. They are again classified into two types: linear data structures and non-linear data structures. Linear data structures are again classified into four categories: arrays, linked lists, stacks, and queues. Non-linear data structures are classified into two types: trees and graphs. And this is the difference between linear and non-linear data structures. And now, coming to this ADT, this is actually the most important topic you need to understand, because we are going to write programs of data structures using C++, which is again subject for your 2-1 semester. So you need to understand what exactly this ADT means. ADT is expanded as abstract data type, uh, but probably you know what is meant by abstract. Abstract is something like hiding the actual details or hiding the implementation details. So when it comes to the definition, the formal definition, abstract data type is a mathematical model of a data structure. That means you can specify what is a data structure, what kind of data is stored in that data structure, and what are the possible operations that we perform on a particular data structure. So whenever we talk about ADT, it means how do you store data of a particular data structure. Then it talks about what are the possible operations that can be performed on that particular data, right? But the thing you need to remember is they don't specify, or the ADT does not specify any implementation details of how those operations will be performed. It only specifies what are the data and what are the operations. ADT will never specify how the data is stored and how the data is operated and how the operations are implemented. It will never talk about that implementation details. So generally when we talk about abstraction, there is always two types of abstraction. One is data abstraction, which means what kind of data structure is used for that. And functional abstraction is what kind of operations are used, but never specify what is the way you are using to implement these operations. So this is ADT concerns. If you read this third point, ADT concerns only with what the data is representing and not with how it will be constructed. And also how we view the data and operations alone without regard to how they will be implemented. So simply remember, ADT mentions the data and its operations, not how they are implemented. So have a look at this now. You will get an idea about this. This is a class created in C++ for creating a stack. Stack is a data structure. So if you look at this class stack, you see that there are three variables: int star, ARR, int top, int capacity. There are three variables for storing the data, and there are six operations, six functions for representing the operations. You can observe that there is no implementation details of these operations. How this push operation is performed on stack, there is no detail about it. How this pop operation is performed on stack, there is no detail about it. Similarly, for all the other operations also, no implementation details are given. So if you write like this, any class followed by a name of the class, the data used, and the operations performed on the corresponding data, data structure, right? So this is called stack ADT. Uh, and what about these functions, where they actually implemented? It means once you declare this, all these operations and the data, you have to define all these functions outside this class. Then the ADT will be fully implemented. Okay, so this shows a sample ADT where you mention the data followed by the set of operations, not the implementation details, right? So this is about ADT, abstract data type. Now, this is a general topic, operations on data structures. These are all general operations. It does not mean that every data structure that we implement must create all these operations or must follow all these operations. That's not true. The thing is, it can use any of these operations. So some data structures use some of these operations, and other data structures may use other operations, so on like that. But have a look at the possible operations that every data structure may be implementing, right? The first operation is create. The primary operation that should be provided for any data structure is create the data structure either statically or uh, dynamically. So either statically or dynamically. For example, if you create a static array by using int a of 10, for example, that means it's a compile time creation. And if you want to create the same array using dynamic memory allocation or runtime, probably in C language we will be using malloc function, or in C++ there is another keyword new, or in Java again there is another keyword new, something like that. Depending on the corresponding programming language, the creation process may vary, but the thing is, you need to create the data structure properly, either at compile time or at runtime. Okay, and once it is created, you can use the data structure for further operations. And then there should be an operation which destroys the corresponding data structure. Why this destroy is required? For example, you have created a data structure and all the operations are done on it. Your, your entire program execution is completed. And now, whatever data or whatever memory allocated for the corresponding data structure should be properly released. So that is the reason why we create this data structure destroy operation. In C language, generally we make use of free function to release any dynamic memory which is allocated for the data structures. If it is a static memory allocation, then there is no need to write this destroy. Anyhow, it will be automatically restored when your program execution complete, right? So you need to write this destroy function only when if the data structure is created dynamically. So you need to release it properly. Okay. And then these are other operations that should be implemented on data structures. One is selection. This is dealing with accessing a particular data element in the data structure. Because the data structure provides a number of elements or it stores number of elements. You are interested in accessing a particular element. So this selection operation should be uh, created or implemented to select a particular element from your data structure. And then updation is about either you are modifying the existing data in the data structure or something like deleting the data or updating or changing anything like that. Searching is an operation where we look for an element. So you need to understand the difference between selection and searching. Selection is access it, whereas searching is just to see whether a particular element is present or not. So you are just checking whether the given element is present in the data structure or not, right? So that is the difference between searching and selection. Selection is selecting a particular element, that means element present. Searching identifies whether an element is present in the corresponding data structure or not. And then next operation is sorting. Sorting is about arranging all the elements in a particular order, maybe in ascending order or descending order. So we all know what is this sorting means. And I think you implemented these two operations in your first year level, searching and sorting operations. Probably the basic search operation is linear search. You might have implemented it. And the basic sorting algorithm is bubble sort. Probably you have implemented it in your first year level. And then the next operation is merging. When you have multiple data items, you can combine them into a single list. uh, that merging operation performs that combining two different lists into a single list. And then splitting is quite opposite to that merging operation, where merging combines two different lists into a single list, whereas splitting uh, partitions a single list into multiple lists. And another difference you need to understand is while merging, the two lists that you are merging must be sorted already. And then merging produces a single sorted list. And finally, traversal. This name is actually visiting every element in the data structure in a particular manner. It does not mean that from the starting to ending you are going to visit all the elements. It is in a particular manner. That means you can visit all the elements from start to end, or end to start, or can begin at some element and then cover all the elements in a particular manner. So it does not matter how you are going to visit the elements, but the traversal operation must visit all the elements in the data structure in some manner, right? So this is about the first session, and the attendance link will be shared in your Google Class, the chat room, or the corresponding LMS chat room. And also there will be a test to understand whether you followed this lesson properly or not. And I suggest you, if you are not able to understand the topics that I have covered till now. I request all of you to go through the video again and try to understand, because this is the first class. Don't worry about whether you understood it or not. You need to listen again and again, and you need to practice it until you understand it. And uh, till we complete few sessions on data structures, you will not be able to follow the terminology used in this data structure, because subject is new. You need to understand the terminology first. Once you understand the terminology, then you will be able to understand the topics that we are covering, right? So I request you to again go through the video, to again listen back this video, and try to understand the basic definitions regarding what is a data structure, mm, what is the problem with selecting data structure, types of data structures, and differences between data structures, and then the possible operations, and the most important topic in this session, ADT, right? So that's all about today's session. We'll continue this session in our next class. Thank you.